What I want to do next for the Atari Video Pinball Board Repair series is to test the lights, which are controlled with the LEDs that are controlled by this array of transistors. The circuit in the schematic looks like this, and from that I built a board that I'm going to populate with LEDs, and it's going to test the circuitry for the anodes and the cathode drives. And when I'm all said and done, in the self-test, all the lights should be on this board when I flip the self-test switch on, and when I turn it off, they should flash like as in gameplay. Actually, as in a track mode, unless the game is going. But if it's in a track mode, then they'll just kind of flash randomly. Anyway, so I'm gonna populate this board that I built. This was built using PCBWAY out of China again, and they do a really good job on these boards. So let me get this populated, and I've got to integrate it into the harness, the test harness I built, and then we'll give it a try. I'm back. I've got the board all populated. I've tested it. It's working. Got it integrated into the test harness using a piece of printer cable with enough wires to hook up all the connections. And so let's turn her on, see what it looks like. Alright, so the game's into track mode right now. So the lights are going through whatever sequence of track mode, like the bonuses increasing and decreasing, whatever. Random feature lights flashing. So if I put it in self-test, they all should be on, and they are. If you have a problem where a row is out or a column is out, I've put on the board what it is to match the schematic. So there's going to be anode 1 through 8. So 1 through 8 increases as you go down. The cathodes are the vertical lines. So cathode 1, 2, 3, and 4. So for example, if all the lights are out in this one, then you would look for cathode 3. The drive for cathode 3 to be bad. Similarly, if like this whole row was out here, you look at anode 4. And basically you go into the schematic and you say, okay, what could be the problem? It's going to be, it'll tell you which transistor, and if the transistor is good, then you would check the drives on these drive chips here, or the inverters. But that's it. Mission accomplished. I wanted to make sure that everything was working on the board. And this lets me check and make sure the lights are working. It does look correct to me. Board still works. You can see the videos there. The only other thing that I want to do is test the plunger. The plunger is like a trackball thing, but not exactly. So I need to look in the schematic on that and see how that is. And maybe I can use a schematic to simulate the the plunger pull. And if I can, then I can play the game. Let me start a game. Alright, so I've already got it wired up. I gotta push start. Alright, so I've got it wired up where I can flip the flippers. You know, one of them's not working. I got a bad connection. Crap. Anyway, I'll fix that. But basically, I've got it hooked up to the joystick for the flippers. But I can't plunge the ball because I don't have the necessary trackball optical interrupter board for that. See if I can figure that one out, and maybe that'll be a future video. But for now, that's it. I've got the circuit board I was wanting to design and build and implement and test all the lights, and this board is good to go as far as that is concerned. All right, thanks for watching.